Hello everyone, I am Xylephian. If you don't know me, I'm a game developer, graphics programmer, tech demo guy, and I like games. Recently there's been a Minecraft update for the snapshot branches, which is 14W29B, well 29A. A lot of people are confused as to what VBOs are and what threading is, and why it's significant in this update. VBO, first of all, stands for Vertex Buffer Object. That's a load of blurb. No one is expected to understand that, except for OpenGL programmers, which is what I am. When Minecraft was first created, it was admittedly, Notch isn't the greatest programmer in the world. He built Minecraft back in the day using OpenGL before OpenGL 2, so I think he used 1.5 OpenGL. The way that worked is you'll say to the graphics driver, I'm about to do something 3D, here's the XYZ for one point, another XYZ for another, and here's another XYZ, and then the graphics driver would say, okay, that's going to be a triangle. When you're ready, I will now draw that triangle. That's called the fixed function pipeline for OpenGL. It's since been deprecated. Deprecated is when a feature is no longer accepted, it's no longer the current norm, so there's now a better way to do things. And the way that OpenGL has decided is better, and rightfully so, is to give more power to the programmer. So we're getting more and more access to the GPU itself. What this means is Notch quickly built a game that used fixed function pipeline. It's built on old world technology from back in 2003. I think that was the last update to OpenGL. I think it's 1.6. That was the last update to the 1.0 branch. But Minecraft never benefited from modern engine technology. One of these things is right in the midst of the generation that Minecraft was first built in, console generation I'm thinking here, the multi-threading paradigm. That kind of rose thanks to the PS3's cell architecture. We gained new ways to do multi-threading in games. The 360 that had 3 cores on its processor, so multi-threading was the future. It was a cheap alternative to making faster processors. Move the problem to software, it's always cheaper. The way that works is on your computer processor, you can pipe instructions down different lanes, and those lanes will operate at the same time. And the idea is to get those lanes to complete their operations at the same time, make them meet in the middle, and then you've done 4 operations within the space that it would have taken 1 operation. So in some circumstances you would have quadrupled your speed, but that's all very finicky. In some programs, too many threads can be a bad thing, because if your processor, say it's a single core CPU with 2 threads available, then having lots of threads in the game engine won't help it at all. It'll start struggling. The operating system itself will have to start managing the threads. That's why the modern CPUs have tons of cores and threads on. And Minecraft was built back when that was just taking off in engines. So they should have had threading from the start in Minecraft. Notch should have implemented it, because that was current game engine technology. But he isn't the greatest programmer in the world, so he just wanted to get something done out in the public. But he's missed out on some core technology which has slowed down Minecraft for a very long time, until these recent updates. So with the snapshot branch, we know that threading has been moved. So each world on a server is now threaded. So the nether, the overworld, and the end, all on the separate threads, all the logic behind managing the entities on that. But now the rendering has been moved onto separate threads. So people who don't know what that means that all the instructions for starting to draw stuff is now on different sections of the processor. So the processor can be told, okay, I now have 5 chunks, 1, 2, 3, 4, 5, start preparing to draw them, and then the processor can, for each individual chunk in those 5, can then start preparing the system to draw them all. The actual drawing can't be done on the different threads, so the actual graphics driver stuff, because OpenGL sadly is still single threaded for the most part. Well, recently that's changing. Minecraft won't be adopting that though. We have, well, chunks preparing to draw on different threads, but that means that their actual physical properties, so the player being able to open a door or walk through it, that's now disconnected. So the actual physical, I can touch this object, is now more distant from the actual drawing process. So in my playthrough, which should be playing the background to this, I have opened a door at one part and walked through the door, turned around, realised that graphically the door never opened, but I could mouse over the hitbox where the single player server, presumed the door would be. So things like that are happening now, and X-ray machines are they can accidentally happen. So at one point I dug away a dirt block or cobblestone block, stood where it used to be, and then the cobblestone block never actually disappeared. So this isn't block lag, don't confuse it with block lag, which is where a server's update takes time to, the client and the server take time to agree that a block has just been mined away or destroyed. So this is more of a graphical bug than a networking bug. Yes, that's threading. The thing is, with really fast processors, threading won't help. So the faster the threads complete, the more useless they become. It's more of a optimization for weaker machines, which most of the Minecraft player base seem to be using. My machine is 3 years old, nearly 4 years old I think. No, it's 3 years old, so 2011, and it runs Minecraft okay. I say okay, 100 frames per second. In this footage though, it's running at 55 frames thanks to my hard drive being slow and recording software using the hard drive to cache everything. So this optimization would be felt by people with multiple cores in their processor on a weaker machine. If you're running it at 4 GHz, then by the time the time it takes to start up a thread and end a thread would be slower than it does to gather all the draw calls for the chunks. So hopefully that explains what this will do to your game. VBOs, vertex buffer objects, that's something that's part of the programmable, well, I say that, but it's part of GPU memory management. Minecraft used to use a fixed function pipeline, but now what the VBOs mean is that we can say there's a common object, keep it in the graphics card memory, keep it in the RAM, because I'm going to be drawing lots of instances of that. So Minecraft's example, cubes, hundreds and hundreds of cubes. So put the cube on the graphics card. Whenever I want to draw it, say, hey cube, here it is, stretch it out, rotate it, shove it in the world, give it a texture, done. It won't need to go to the processor, you won't need to say, okay, I'm going to draw another cube, here's a point, here's 36 points to show all the triangles on the cube, run wild with it. So that was the original method. Now it's just say, cube appears, everyone's happy. This also means that some more interesting things can be done potentially. So modders would be able to replace all the cubes with spheres. Quite pointless. They wouldn't line up properly. But things like that could be done quite easily with VBOs, and there won't be much headache. The benefits for that though is literally the graphics card will have milliseconds to pull out the data and slap it onto the screen buffer. What gets displayed to you. Yeah, this is a good path for Minecraft to go. It does require OpenGL 2. I think VBOs were an extension of 2.0 and 2.1. But it's something that kind of should have been done at the start. There's been a lot missed out in terms of performance with the game not having these features, so it's props to the programmers. It's very difficult to add these kind of optimizations late into the game. It should have been done from the start. But everyone's going to be happy that performance is suddenly amazing. There's still a bottleneck of JVM, which is the Java virtual machine that Minecraft runs on. The only way to speed that up is to throw power at it. So if you're on a terrible computer and it runs terribly, you will need just a better computer. It's the only way to get around the JVM problem. Things will get better. especially when shaders start getting introduced for the actual surfaces. So we have screen space shaders currently with the super secret settings, or you know, the mob vision that does that. When we start having shaders done for cubes, we could say the grass cube, wood plank cube, they're the same objects, same VBO, stored in graphics memory. Grab cube quickly, slap it with this shader, grab another cube quickly, slap it with this shader, then you have two different cubes, or same cube, two different textures. So that's the kind of benefits we'll get from that. So the bugs we can expect to see is a disconnect between physical properties, so collision bounding boxes, and the world geometry, so the chunks. That's something I've already experienced. There will be some visual lag for computers with slow server tick. So if your server software is taking too long, well, the Minecraft chunks, they exist quite heavily on the hard drive. So if you're like me and you have a slow hard drive, you will notice that when you punch away something like a flower or grass, there will be a slight delay before that disappears. But yeah, you shouldn't notice anything special with VBOs. That's to do with the threading. That's all I have to say about it, really. Just wanted to clue people in, because I know a lot of Minecraft players have no idea what this stuff means. And quite frankly, they find it boring. Have a good day, or evening, or wherever you are. I never know how to finish these things. Oh well, good thing I don't do too many YouTube videos. I'm too busy programming. Okay, bye! Bye! Have a good one, bye! Bye! Bye!